Okay, this will be part 16 of the Raspberry Pi Set Up Your Own Raspberry Pi Linux Python MySQL database series. I have not in previous videos gone deep into my data logging script. I've had several questions about that over the time that I've had this series up and been developing this series. So today we're going to go into that. So without further ado, let's jump right in. I've created a demo file here of it so we can go through and have a look at it, and we'll go ahead and get started. I guess I should say I usually use Emacs for editing through SSH. If you're working directly on the Pi desktop, Thonny, Thonny, Thonny Python editor is pretty nice for that. One thing I find it doesn't do well is accept really long lines. End up having to scroll way out to the right, whereas Emacs will truncate the lines with basically a blank space, sort of. So Emacs is an excellent program, especially if you're editing through SSH. A lot of people use Nano or VI. There's a couple others. Emacs I find is really nice because it color codes everything in Python, and it really makes things stand out easier for what you're doing. So we'll just go ahead and jump into that. So I guess I should say, if you want to install Emacs, it's sudo apt-get space install space Emacs. So here we go. We're going to jump into the Python script here, and we'll just go ahead and get started. At the top of the file, there's a few modules you want to import. The first one we import is sys. That's a system for Python that helps it with functions and all the different sort of Python code related stuff. That's a necessary one. The next one I import here is rpi.gpio. And you'll notice we import that as GPIO. That's basically to interface with the input-output GPIO pins, especially for the relays, like for setting the pins high or setting them low for turning relays on and off. And we import that as GPIO so we can reference GPIO later in the script, which you'll see later in the script. The next command is import OS. That's relevant to the operating system you're working on. In this case, I'm working Raspbian Linux. Actually, I think it's Buster. It's the latest version, but that's relevant, so that's a good one to have. And then if you have an Adafruit humidity sensor, either the DHT11 or the DHT22, you'll need to import the Adafruit DHT module. You'll need to download that also. If you don't know how to do that, that's in one of my previous videos in the playlist. The playlist for reference is Set Up Your Own Python MySQL Raspberry Pi kind of thing. Look in my playlist and you'll see it there. Let's see. So once we've done that, we're going to we declare the sensor Adafruit DHT22, and then we declare the pin that's working on. That's DHT pin equals and the pin number. In my case, that's hooked to pin 24. So that's why we could declare DHT pin equals 24. You'll see how that's relevant later in the code. We import PyCurl. This is used for posting to HTTP, and I believe this also helps to pipe data to the database. So PyCurl is a pretty handy tool. You'll need to import that as well. And then we come down here, and I'm running a combination of Python 3 and Python 2 stuff, so we basically are just supporting both options here. We try importing Python 3, and then if we can't import Python 3, we pull in Python 2. This code will all be available on hamradio.cc. I'll put a link in the bottom of this video when it's done uploading, and so you'll be able to copy and paste this code if you want. We import time. That's for the time.sleep function, so you can do delays between things or inside of loops. That's a critical one to have. And then we do a GPI set mode GPIO.bcm. That's basically telling the GPIO that we're using the GPIO for Broadcom, and we're using the Broadcom pin numbering. Then we go down and we say GPIO set warnings false. That's so you don't get all sorts of warnings when you send commands to the GPIO pins. I'm not going to get deep into that at the moment, but we also call a pin list and we tell it which pins we're using. In this case, that pin list is for the relays. There's a 8 relay board connected to my Raspberry Pi, which controls pumps and venting and all that sort of stuff. So any pins that you're going to be using, you'll want to put in your script for wherever you're using it. I don't think I actually have any relay controls run through this script now. I think they're all outsourced into other scripts specifically for ventilation, heating, cooling stuff, but it doesn't hurt to call them anyway. The next thing we do is we connect to our database. So we import MySQL DB and then we connect to the database. I've substituted in fake username and password here, so I don't share my usernames and passwords out on the internet. But basically, it's pretty simple. Connection equals mysqldb.connect, and then inside the parentheses, you call for the host. You tell it what host. In my case, it's localhost. Chances are pretty good you can use that if you're hosting the database on the Pi. If you're hosting it elsewhere, you'll have to understand, how to reach your SQL database on your local system. But if it's on the Pi, localhost is fine. And then, of course, you'll need your username and password for MySQL. You'll plug those in, and you'll have to call the database with the name of the database. In my case, my database is called Solar. So where I have DB name here, you would change that to Solar. And if your username was, say, user, you change it to user. And if your password was password, it would be password. Just to be clear there. And we close that, basically kind of contain that with x equals connect.cursor. So now we've imported and set up a connection to the database. You'll see how that's relevant later when we pipe the data from the script to the database. A couple of the things that I do grab here, it took me some time to figure these out, a little bit of web research, but I found it very useful for diagnostics on my Pi. I actually capture RAM-free, RAM in use, and RAM total, all that kind of stuff, as well as CPU temperature and disk space. I capture all that stuff and I pipe that all to my database. And I find that's very useful if you have a crash. Later on, you can go back and look at the database. For example, if you have a cooling fan system, like I have an external additional cooling system for my Pi, if that fails and my Pi crashes and I don't know what happened, later on when I go back and look in the database, I can see if the fans failed and the CPU temperatures were climbing before it crashed, and that'll help give me a little more insight on why it crashed. So that's why I do that. You don't need any of this to collect one-wire sensor data or humidity sensor data. It's just something I find very convenient for diagnostics for later, and something I like to monitor if you haven't figured it out yet. I'm big on collecting as much data as possible, and then you can always analyze it and use it in a powerful way or as a powerful tool later on. Anyway, you can see we just define the function get RAM info. We go through and split that out to usable data. I don't want to spend a lot of time on that. And then let's see, the one thing I always do with when I'm writing a script now is I use the print command, and I print out all the data as I run the script. That's not for when the script is running on the cron tab in the background, which is how I usually run it. The cron tab runs a script every minute and logs all the data it collects every minute to the database. But when you are writing the script, when you're writing the code, if you run into an issue or you have a sensor that's failing, this is a great way to see what sensor is failing as to where and why. So that's why I use the print command for all values that I call. I use the print command afterwards, so it'll show up when I run the script. I'll show you that momentarily. Actually, I'll show you that right now. If I can. Get out of the program. There we go. I'll just run. I'll run the the actual script real quick. And you can see that using the print command, I'm piping everything, all the data I'm collecting, and printing it back out here in the terminal, so that if there's a sensor issue or if I have a sensor on the wrong thing, I can easily see like, oh, that's the outside sensor and it says 120. That's way out of range, so I know I have the wrong sensor address or something like that. So that's all I'm doing there. So we'll go back into this demo file and pick up here where we were. Excuse me. Let's see, CPU temperature I do find very useful. I probably would recommend you do grab that and pipe it into your database. It never hurts to know what your CPU temperature is operating at. So we're just doing another defined function, define get CPU temperature, grabbing data from the operating system and then piping it to a variable in the Python script, and then later on we pipe that into the database. Also grabbing CPU use. You probably don't need that, but I find it handy. After that, we get down into, I didn't go over this quickly. So this right here, this section where the cursor is to where the return temp is, basically what we're doing, if you've seen my other videos and you know about diagnosing or looking for the sensor addresses for the DS18B20 sensors, you'll know that we do a list sys bus w1 devices, and that gives us addresses like 28 dash whatever for each sensor. And so if you look here closely, you can see that we're basically creating a text file. We're grabbing the address of the sensor, and then we're pulling the sensor, grabbing the database into the text file, and then parsing that out to a readable value. And then later on in this part of the script, we actually take that and convert it to a Fahrenheit. So you can see where we change the decimal here with it dividing by 10,000, and then we multiply times 1.8 plus 32 to get a temperature in Fahrenheit rather than Celsius, and then that returns the temperature. So this is kind of a module for each time we poll a sensor to grab its data and parse it to a value that's readable to us or readable to the program. So then after that, we just start, calling temperature addresses and declaring variables. So for example, outside temp equals read underscore temperature, and then you see in the brackets and parentheses there, we're calling the address of the outside temperature sensor. And you'll notice that for each one of these sensors, there's a different address here, right in here. And that's, so each of those sensors is being called, polled, its data grabbed, and then that's being declared as a variable in the script here. And you'll see that we pipe that later on into the database when we do the insert or x insert into the database with x.execute. Again, I'll just mention here, you notice I grab the data, and then my second thing I do immediately after I grab it is I print it. I really find that's very handy. I highly recommend you do that. So you're saying print outside temp, and this outside temp here is just given a textual value so you know which sensor you're actually printing. And then after you close the quote and you put the comma there, you're calling the variable that we just defined here out here, and that way you get the actual data value back out. So it's telling you that it's the outside temp sensor that you're looking at, and then it's telling you what the temperature is on that sensor. Again, I highly recommend doing that if you're writing code, especially if you're new to writing code. It will help you tremendously in diagnostics. You can see, like here, I used to have a peak sensor in the greenhouse. That sensor went bad back in the spring. To keep this simple, I just declared that value as 0. That way I know the sensor's not working, but I didn't have to pull it out of the code or pull it out of the database insertion. So that's why you see the peak value set at 0 there. We go on down through all the other sensors in here. I used to have like 28 or 32 sensors in the greenhouse. I think we're only running like, 8 or 10 now. But you can run a tremendous number of sensors. and have no issues. So in my case, because I'm using a greenhouse and thermal masses, and I want to know what the BTUs I have in storage are, and manage and monitor that, I do some calculations later on in the script here. So I'll just explain these real quickly. Hot 3 that I'm declaring here is the sensor that's on the thermal mass that's on top of the stove. That's the big stainless steel pot. I used to have 2 sensors for that inside the pot, an upper and a lower, because there is a pretty large difference between the upper and lower temperature. So that's why you see this H average here. I used to average those 2 together. I'd take hot 3 and hot 4, add them together, divide them over 2. That would give me an average and a more accurate BTU value of the thermal mass there. But since we're only running 1 sensor now, obviously I'm just calling the average as hot 3. And then now, let's see, I calculate the T-mass average. This is for the large thermal mass tank. That's the 275 gallon tote that we pump heat to from the stove. Again, you'll see I'm looking at the T-mass temperature up high and the T-mass temperature down low in that tank. I have a sensor about 6 inches from the top and another one about 6 inches from the bottom. And that gives us a much more accurate assessment of how many BTUs are actually stored in that tank by taking the high and low temperature, dividing over 2. We're basically averaging. So that gives us a T-mass average. The other thing I use is a D-heat. That's the difference in the average temperature of the thermal mass on the stove and the average temperature of the thermal mass in the large thermal mass tank. And then that not in this script, that's not used to turn the pump on and off, but in another separate script, that same value is used to turn the pump on and off when the difference between the two is greater than 20 and when the hot pot on top of the stove is greater than 120 degrees Fahrenheit. So it's a good value for me to track for what I'm doing. Then I come down here and I look at the differences between the two, and I calculate BTUs. So like this 2374, I think that thermal mass tank is like 275 gallons it's rated at. I think I figured it to be a little bit more than that. Anyway, if you take the value of 1 gallon of water, which is 8.33 pounds, and you multiply that times 275 gallons, that gives you 2,290 BTUs per degree Fahrenheit of rise or fall. And you'll see that this value is pretty close. I chose 2374 because I topped that tank right up, so it's probably closer to 300 gallons or something like that. I guess we could just calculate that real quick. Yeah, it looks like I'm looking at that at about 285 gallons. So that's why you see that number, but that's how I'm calculating BTUs. For every pound of water raised or lowered 1 degree is 1 BTU. That's in Fahrenheit. So then if a pound of water is 8.3, or a gallon of water is 8.33 pounds, then obviously you can do the math from that, and that derives BTUs for you. So that's how I track BTUs. For a quick reference, we'll just take a quick look at my charting program here. I'm using a free program called SQL Dashboards until I get the new web-based interface code written. And you can see here, this is average greenhouse temperature here. This is a stove temperature. You can see how that climbs and drops significantly. Like for example, yesterday, a little after 4 o'clock, the stove was started up. You can see the stove climb rapidly. I had taken the pump for the thermal mass out and switched it over to another tank for heating water for the shower. So even though the stove is running and the pump was running, you can see the large thermal mass was still declining. And you can see where I switched it out of the shower water barrel and put it over to the main storage tank. And you can see where it started taking on BTUs. And you can see I was stoking the stove heavily last night. We had some really wicked winds and some pretty cool weather. Not super cold out, but the winds really take a lot of heat off. So you can see I was banking BTUs through here. And let's see, you can also see that reflected in, I have the T-mass average here, and you can see how that was climbing as soon as we added that in. So just for reference, so you can see, you know, how this works in real time. All right, back to this. So I'm basically just calculating BTUs for the different tanks. You know, like, let's see, T-mass Delta 2 BTU stored 2. That's the tank to the left of the stove. That's the one that's not having pumping through it, but it's right next to it, so it does collect heat. And then hot 3 is the tank on top of the stove. And then I also do a BTU total, and collect that. Of course, you could crunch and calculate all this stuff on the fly as you represent it in code later if you wanted through PHP or any other method or mode. I like to have those values stored in the database. It doesn't take that much extra work to do it. All right, then we come down here to the Adafruit DHT22 humidity sensor, and we define the function for that. Define get humidity sensor data. We call a loop, we call a value, and then we say while the loop is less than 5 and the relative humidity value is equal to 0 or greater than 100, which is why that's not working right. That should be a less than 100. Anyway, basically what we're doing is saying that the range for this sensor that's valid is between 0 and 100 for humidity, and anything outside that range, we're going to discard that, and we'll restart this loop, and we'll go pull the sensor again. Sometimes these sensors don't report reliably, so sometimes it's necessary to pull it a couple times. I've gotten readings up to, you know, up to 999 for humidity, and also down to negative 999. And so in order to not screw up my charts and my data, I've set this up in a loop so that we go through and we try several times. Of course, it's also humidity and temperature both, and so you can see here again, we're calculating for the temperature, we're calculating from Celsius over to Fahrenheit. You can see we take a 3-second delay between attempting to read this, trying to give the sensor a chance to reset. These DHT22 sensors are fairly slow. When I switch over to the Arduino, I may look at some sort of an analog humidity sensor and pull it into analog to digital conversion. But just kind of wanted you to understand what's going on here. So then we return values from that, and then we declare them here with humidity and hum temp. And you know, you can see that points to that function that we've called. And of course, we print those out so that we know that we're actually collecting the data. And then the last thing we do here is insert that data into the database. Now, I've covered this in a previous video, so I'm not going to go really deep into this, but I will just kind of graze over it quick with you. So we're using the try except function here. That way, if we have a failure, instead of just failing and stalling, we have a way to fall out of that, and we'll know that there's a failure going on. So we use try except. So we do try x.execute, insert into temps, and then we pipe values. The first set of values for this here, these are the database variables that are going in, and then we call the values, and we pull those values forward from the values that we've called, from the variables that we've called in Python, which is this last set of names. And then you can see for values, like for greenhouse ID, that is always 1, so we just pipe 1 through to that. We just declare it right in here. And then the other values, because we're pulling those from predefined values, we're using %s as a replacement in the transfer, and so the code grabs the temperature value and hands it over and passes it to the database. So that's how that's set up. And then if you look at the end of this line here, you see we're pulling date time, and that corresponds over here to date time. And you'll notice that's a little bit weird looking, but when you think about it, it's year, month, day, hour, minute, second. Again, I'll make this stuff available on hamradio.cc so you can copy and paste if you want to set up your own thing. Then finally, we commit that to the connection. Remember earlier on, we opened a connection to the database after we imported MySQL DB, and And so now we're committing that data to the connection and sending it to the database. If that fails, we go accept, we roll back the connection. In other words, we disconnect from the database, and then we have a print command that comes out and says end of database insertion. So if this function fails, instead of inserting to the database and seeing truncated values, you'll end up with end of database insertion. So what I'll do is close this. We'll take a look at how it would normally operate, and then I'll come back and I'll open it and I'll screw up one of the values in here so the database will fail, and you'll see the difference between the two, just to be real clear. So let's run root demo. Well, let me run OW new. That's the actual running script. Okay, and so you can see it's going through, it's pulling the sensors, it's grabbing all the data, it's crunching for BTUs and all that kind of stuff. And yeah, you see data truncated for column. That's because these sensors have greater than 2 decimals after the decimal point in value, and so it's just truncating off the extra values after the 2 decimals. I've set my database up so that I don't consume a tremendous amount of space for precision that I don't need. That's pretty much it. Now, if that fails, instead of getting all that database truncation stuff, you'll just see this last line here, right here, end of database insertion, and you won't see any of the truncated values. So that's how you know you have something wrong in how you're inserting data to the database. I think that's it for now. I hope you found this informative or interesting. If you have questions or comments, please do so down below. Yeah, I think that's it. So thanks for watching the Pharmacy Seeds Network. I hope this helps someone. Again, if you have questions or you get stuck, don't be afraid to ask, and I will post this code and any other pertinent information over on hamradio.cc, and I'll provide a link below underneath this video. Thanks for watching. Hope you'll like, share, and subscribe. Catch you in the next video.